All right, so in 29, we're trying to find A and B that makes the statement true. So before I talk more about it, let's write the question down. 5A minus B plus 2B plus 4A times I is equal to 36 plus 26I. All right, so how do we find A and B to make this true? Now, on the right here, we have a complex number in standard form. So a complex number in standard form looks like this: a plus bi, right? Different from these a's and b's, not to confuse you, but that's a complex number. It has a real part and an imaginary part. All right, a and b are real numbers, okay? But a is called the real part, and bi is the imaginary part because it's being multiplied by I. So in order for this to be a complex number, then b can equal 0, because if it is 0, then you just have a, and that's a real number. Okay, so now what we're going to do is we're going to set 5a minus b equal to 36 because we want the real part to be 36 according to the way this question's set up. And then we'll set 2b plus 4a equal to 26. Okay, so now we have to solve that system of equations. So to do that, I'm going to take both sides of the equation and multiply it by 2. So I get 10a, which I can write right here, minus 2b, and then on the right side I get 72. So I'm going to add, this cancels out, I get 14a equals 98, all right, and then 14 times 7 is 98, so 98 divided by 14 is 7. So now I have a. Is that right? 70 plus 28, yep, very good. So I have a is 7. Now to find b, I could just finish solving the system by taking one of these original equations and plugging in 7 for a. So 5 times 7 minus b equals 36. And then we get 35 minus b is equal to 36. Subtract 35, divide by negative 1, and we get b is negative 1. All right, then we could check our answer by plugging in a and b into the original, and we get 5 times 7 is 35, minus negative 1, plus 2 times b is negative 2, plus 4 times 7 is 28 times I. All right, and this becomes 36 plus 26I, which is exactly what we want it to equal. So there you go. There's A and B, so that the statement is true.